All right, let's look at some applied problems that use the law of cosines. So on this one, Mordecai and Rigby start out at the same point. Mordecai walks 100 feet in a direction 10 degrees east of north, and Rigby walks 50 feet in the direction 20 degrees north of east. How far apart are they? Okay, well, let's see. We start out, they're both going north and east, so I'm going to come down here for my starting point. So I'm gonna draw out a thin line here and here for north and east. Okay, Mordecai walks 10 degrees east of north. So what that means is, if I come over here, this angle, this is of course north and this is east. So 10 degrees east of north, that means this is a 10-degree angle. And so he walks out here 100 feet. Then Rigby walks 50 feet in the direction 20 degrees north of east. So what that means is you come out here in the direction east, like over here, and then you move up, so this is a 20-degree angle. But he only walks 50 feet. So this is 20 degrees. And these lengths, I'll do the lengths in purple. This is 50 feet, and this is 100 feet. So what we're asked to find here is what is the distance from Mordecai to Rigby? So that's from here down to here. So we're supposed to find the length of that green line. All right, so we've got to figure out what is this angle inside of here. This angle in here, notice if you go from here around to there, that's 90 degrees. But we've got 20 degrees taken off of it on the bottom and 10 degrees taken off up here. So the angle we're interested in is this one, which is 60 degrees. So we're trying to find this distance over here. I'm going to call it C. So C is what we're trying to come up with. And I could take this and draw it as a separate triangle and label all the sides with A, B, and C and all that. But I don't want to do that. We're trying to find this C. So C squared, let me write this in black. C squared equals A squared plus B squared minus 2AC, it's AB cosine C. And so basically I've got my, I'm treating this as my angle C. And these are my A's and B's. It doesn't matter which is which. So I get 50 squared plus 100 squared minus 2 times 50 times 100 cosine 60 degrees. That 60 degrees looks kind of like a 600. Let me fix that. $60 degrees. All right. So it's just a matter of working that out. Let's see. 50 squared plus 100 squared minus 2 times 50 times 100 times cosine 60. That's nice. Cosine 60 is just a half. So this gives us an actual nice number. So C squared is 7,500. Now this is an applied problem, so instead of taking this and reducing it to a radical, let's just take the square root of it. 7,500 to the half power, 86.6 feet. Or you know what? Let's also write it as 86 feet. And on my calculator, I've got all this stuff in here. It's 86.605 feet. Let's subtract off the 86 feet. So we're left with 86 feet and this fraction of a foot. I'm going to multiply that by 12. 7.23 inches. or 86 feet, 7.23 inches. All right. Let's look at this last example. On a baseball field, the distance from the pitcher's mound to home plate is 60.5 feet. The distance from home plate to first base is 90 feet. How far is the pitcher's mound from first base? All right, so on a baseball diamond, you've got, let me do that again. You've got that, I can't seem to draw this. Let me actually, all right, one last time. All right, so this is our baseball diamond. Here's home plate, here's first base, and the pitcher's mound is, it's on a straight line up here, but it's not in the center. It's actually a little closer to home plate than it is to second base. So what we're trying to do is figure out, what is this distance here? Instead of question mark, let's call it C. And what we're given is, let's see, this distance here from home plate to the pitcher's mound, that's 60.5. And this over here is 90. Now, they don't give us any angles, so I guess we have to have some baseball knowledge. This is a square, and so this is 90 degrees here, and so this angle here is 45 degrees. So it's a lot like the problem we had before. We're trying to figure out this C up here. So this is going to be my, this will be my A and my B. And 45 is my capital C. So let's see, we're going to use C squared equals A squared plus B squared minus 2AB cosine C. So A squared plus B squared. I'm going to move this over. Actually, I'm going to move all this stuff over. So we got 90 squared plus 60.5 squared minus 2 times 90 times 60.5 cosine C, 45 degrees. So just plug it in the calculator and chug away. 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times cosine 45. Okay, that gives me C squared is 4059.857, and it keeps going. So take the square root of that, 63.7. 7.7 feet. Let's convert that to feet and inches. That's 63 feet. And so this fraction of a foot over here, 0.717, if I multiply that by 12, that gives me 8.604. 63 feet, 8.6 inches. All right, so that's it.